Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of line in R3. So as per the problem, determine the parametric equations of the line whose direction vector is perpendicular to the direction vectors of the two lines and passes through the point 2, -5, 0. So we have to find the parametric equations of a line. First, we'll find the vector equation of the line. So let's start by writing the general equation of a line in vector form. In this equation, vector r represents the position vector of an unknown point that lies on the line. Vector r0 is the position vector of a known point that lies on the line. T is a parameter and it can be any real number, and vector m is the direction vector of the line. So first we'll find the direction vector of the line. This direction vector is perpendicular to the direction vectors of the two given lines. Let's find the direction vectors of those two lines. These two equations are given in symmetric form. So the components of the direction vectors of these lines are in the denominator of the fractions. So for the first line, the direction vector is -4, -7, 3. And for the second line, the direction vector is 3, 2, 4. Now the direction vector that we have to find is perpendicular to these two direction vectors. So we can find our direction vector by doing the cross product of these two direction vectors, because cross product gives us a vector which is perpendicular to the two vectors for which we are finding the cross product. So our first step is now we can calculate the cross product by stacking the y, z, x and y components of these two vectors. So in the first vector, the y component is -7, z component is 3, x component is -4, y component is -7. In the second vector, the y component is 2, z component is 4, x component is 3, and y component is 2. Now we can calculate the x, y, and z components of the cross product vector. So let's start with the x component. And for that, we should cross multiply the y and the z components. So we start with -7 times 4 minus 2 times 3. I get x equals -34. Now we can find the y component, and for that we should cross multiply the z and x components. We start with 3 times 3 minus 4 times -4. I get y equals 25. Now we can find the z component. We should cross multiply the x and y components. Minus 3 times -7. I get z equals 13. So that means the direction vector m is equal to negative 34, 25, and 13. We can use this given point that lies on the line for direction vector r0. Now we can write the vector equation of the line. Next, we can break up this vector equation into parametric equations. So for that, we'll have to use an unknown point x, y, z that lies on this line. Now we can write the x, y, and z equations. So for the x equation, we'll use the x components of these three vectors and we'll multiply the components of the direction vector negative 34, 25, 13 by t. This is the x equation. For y equation, we'll use the y components. And for z equation, we'll use the z components. We can ignore the 0. So it's just z equals 13t. So these are the parametric equations for the line. So this should be the final answer. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.